you look at the way a plant makes chemical energy. It takes sunlight, it takes water, and it uses sunlight energy to split the water into hydrogen and oxygen, and it takes carbon dioxide and reduces the carbon dioxide and builds a hydrocarbohydrate, okay, that we can then turn into a sugar that can turn into a fuel, or we can eat it. It's also a fuel. And so the question is, can we design, using nanotechnology, something that begins to replicate what a plant does, but we have an advantage. We have access to materials that the wet biological world doesn't have access to. Therefore, we can, in principle, design something better. Just as when we learned to fly, we started by looking at the way large soaring birds flew. And the Wright brothers' plane actually had these big wings that warped around, and that's how they, just like large soaring birds. But they used the gasoline engine instead of muscle power. And now today's jet engines use materials that nature can't produce. Single crystals of metal in the turbine blades, as an example. So the question is, can we do this in artificial photosynthesis with the design, make it 10 times better in a plant, skip the hydrocarbon, go from water to oxygen, hydrogen, carbon dioxide to a hydrocarbon fuel? It's been around for a while. We decided that in the last couple of years there's been enough advances in science and nanotechnology that we have a shot. In maybe 5, 10 years, this can really happen at a cost-effective way. And so an energy innovation hub has been started to fund that type of research.